Welcome to MathSolve. In this video, we are going to see the gradient of two parallel lines. And the first line we are just marking as line 1, and the second one we can say line 2. Okay. So what is the gradient of line 1? And as you know, the gradient is basically rise over run. If I said that our line 1 is m1, the gradient of a line 1 is m1, which is rise over run. And if I just make a triangle here, probably I can just use that different color. So let's say we are creating a triangle here, so which is rise by 4. You can see 1 2 3 4 4 step up, and we are going 2 step in the horizontal direction, so our run will be 2 and the rise is 4, so it's giving us the gradient 2. And for m2, if I do the for the gradient m2, so gradient of the second line, again rise over run, and again if we make a the maybe we can just go all the way here and then go all the way rise to make a right angle. So you can see that we are going our rise will be 6 and then our run is 3 steps, so which makes 2, so gradient same. So if you go rise over run, it gives the gradient sum. So I can say that the gradient is same if the lines are parallel. So this is the relation of the gradient if the lines are parallel. And we can see also in other way. So if we have you know that the angle created by this, or let's say is alpha, and the angle created by the x-axis for the second line is creating beta. Okay. Now so what is the gradient? m1 is tan of beta, right? And m2 will be tan of alpha, because we know that it's a tan of the angle created by the positive x-axis. That's the gradient. And also in other words, tan theta equal to rise over run, right? So it is tan alpha. So it's tan alpha equal to opposite over adjacent. If you know that for alpha this is opposite and this is adjacent, so again you will get the same things too. So now we know alpha and beta is same. Why? Because they are corresponding angles. I can just write down corresponding angles. So they are corresponding angles. That's why alpha and beta same. Why they are corresponding? Because alpha, the line 1 and line 2, they are parallel. So if the x-axis is working as a transverse, and you know the alpha and beta will be the correspond to each other, so they are equal. And if alpha beta equals, so tan alpha tan beta will be equal, right? So if I say tan alpha equal to tan beta, so I can straight away write down m2 equal to m1, because we know the tan alpha is m2, so m2 equal to m1. So we can see that m2 equal to m1 for the parallel lines. Okay. Now if I ask you what is the equation of line 1, so you can just straight away say line 1, the equation of line 1 will be y equal to mx plus b. If I write y equal to mx plus b, what is m here? We know that for these lines, all these lines, the m is 2x. So y equal to 2x would be the same for any line parallel to these given lines. And what is b? B is the y-intercept. For the line 1, our y-intercept is sitting here, which is 1 2, so minus 2, because minus 2 is the y-intercept. If you go for line 2, if I ask what is the equation of line 2, you can straight away say y equal to 2x is the same, because the gradient, if you even count, is the same. Y m2 is the gradient is 2, so 2x. And then what is b? In this case our b will be positive 6. You can see y-intercept is positive 6. So it means any line parallel to these given lines will give you the y equal to 2x, but the b is depending where it's intersecting the y-axis. For instance, if I just make another line which is passing through x-axis here, then definitely it will pass through y-axis in the 2 step up. Why? Because we know the gradient is 2, so rise would be the 2 times then run. So that's why if I put here, then other one will be 2. If I give 3 down, then it would be 6. If I 4, then it would be 8, because it's 2 times, because the 2 is the gradient. So now if I just connect these points or even extend it now, then you can see you are getting another line which is parallel to the other 2 lines. And if I ask you what is the equation of that line, you can just straight away say y equal to 2x is the same. Only the difference is y-intercept, and here is y 2x plus 2. That's all. So what we learned here, we learned that the parallel lines shared the similar gradient. So any line parallel to each other, their gradient will be the same. Thanks for watching. If you'd like to see more up-to-date videos, please subscribe my channel.